Okay, Dr. Pingle here. In this section, we're going to talk about using a few of the other tools that come with the LAStool toolset. This is the directory that we unzipped to. You can see that we've got 64-bit versions of most of these, but the list is pretty long. So I'm not going to try to teach you all of these. I haven't used all of these, but some of them are particularly useful. So let's start with LASview. LASview is a really simple Lidar viewer. So if you open it up, you get a GUI that starts like this. And you can browse to find your Lidar data that you've downloaded. So I'm just going to take a look at this one from the Blacksburg area. When you open it, it looks something like this. So obviously that is not a lot of Lidar data. What you need to do is hit View. So View is going to basically run this little command. What you're seeing here is just a little wrapper for the program. This is going to execute using an input file of the one that you downloaded. So it looks something like this, which obviously doesn't look a lot like Lidar data either. If you right-click on this, you actually get a number of different commands that you can execute. So we're not going to try to use all of these here, but I just wanted to show you a few. So one of them that's important is color by. So you can color by classification, elevation, intensity, return, RGB data, color data, if it has been attached, or flight line data or any other user data that you're interested in. We can color by classification first, which is actually what the default was. We can color by intensity, which looks a little bit more familiar. So here you can start to see the difference between trees in the ground and roads. And this is a three-dimensional viewer, so you can move this point cloud around. You can zoom in and out. Space bar is going to control whether you're panning, translating, or zooming. So if I hit the space bar, you can see that in the upper left-hand corner it goes to translate, and now the point cloud is moving left to right. If I hit the space bar again, I can zoom in and out. So I'm moving the mouse just kind of through the screen to move in and out. A little bit of an awkward interface. So tilt means I'm just tilting it around here. Pan is a little bit more maybe familiar. So you're basically kind of getting a chance to move around the point cloud. Again, this is not, it's quite a bit less intuitive than Cloud Compare, but it is very lightweight. There's a hotkey for colorizing, and that's the C key. So if you hit C, you can move through the different coloring schemes. This one is coloring by elevation. So here you can really see the trees on the ground surface. Excuse me. So the two most common are probably going to be coloring by elevation and coloring by intensity. So if you cycle it through long enough, you'll come back around. But that's a quick introduction to LASviewer. I don't really use this one very much since it's so easy to use with Cloud Compare, but it's still nice to know that it's here. There are a couple of other really useful ones. So we're going to use one called LASmerge. We're going to use LAS to LAS to do this one. So if you click this one, you'll get a screen that looks something like this. Again, you should be getting kind of used to those by now. If I go back again, I get to a directory that looks something like this. And I can actually load all of these into the viewer. So I'm just clicking on all of these in turn, and it's loading them all into my box. All right, so there's all 9 of the Lidar tiles that I'm interested in. What I want to do is I'm actually going to save these things as output. So we're going to do output. The directory here can be whatever you want. I'll use my current directory. So that's going to be, you kind of see the C temp Blacksburg. Scoot that out a little bit so you can see it. Again, the GUI is pretty basic, so It's a little bit awkward, I grant you. The file name, we're just going to call this merged.las. And then I'm going to click an additional output here, which is to say merge the files into one. So this is going to be the difference versus processing each one of these in sequence and aggregating all of these together. So this is going to stitch the whole point cloud together, and we're going to get one big point cloud instead of 3 smaller point clouds. And then we just hit run. We can either do the 32-bit version or the 64-bit version if you've got a 64-bit processor, so I'll try that out. You can see that we are using a list of files that's going to get specified here. We're outputting this stuff. And notice, by the way, that this got changed to merged.las. I'm going to fix that. And put LAS here. We'll run this again, and actually we can just change that right here to save it as merged.las. So you want to just give that a quick look. So just to give you an idea of what is going on here, we've got LAS to LAS. We're reading in a list of files that the program itself is auto-generating. We're merging them together. We're saying what my output directory is, and then we're specifying our output file. I'll show you how to do this one in the command line since it's quite handy to do it that way. But I'm going to hit start. This is going to just take a second to complete. And if we look in our directory where our Blacksburg data was, we should now have a merged.las file now that the program is complete. So it's about 300 megs. So that's, each one of these is about 40, so that math kind of works out. The file name didn't turn out quite the way I expected, which is fine. And we'll just double click on this and look at it in Cloud Compare. Now what you'll see here is just again, all 9 of those tiles put together. The top 6 of which is what we've been using in previous labs. But I wanted to get the stadium in this particular rendering. Again, we've got this rendered via a scalar field that corresponds to something that we don't particularly care about. And so we're just going to do a quick display, quick tools, scalar fields, and then export coordinates to SF, which is going to write the Z coordinate as a height field. Now you notice that this all looks green. That's not really what we want. The reason for this is here we go. The reason for this is we've got a lot of things out of bounds here. So if we just scoot this out, what's going on is there are actually some outliers. So if we look really carefully, you can see that the top of this bounding box goes quite a bit of ways above the ground surface, and that's why it doesn't look great. We could do some of the things that we've done before and add a shader in here to make it a little bit clearer. So now you can see pretty clearly the stadium down here. We've got the drill field over here, and then kind of the rest of campus all around it. Okay, the last tool that I wanted to use is called LAS bounds, which is going to create a shape file that corresponds to the boundary of this data. So we can exit out of Cloud Compare. We won't need it for a moment. We can exit out of that as well. And if we go back into LAStools and binary, we'll see LAS. Oh, where did it go? LAS boundary. So you'll click on this, and you're going to get something that looks like this. Now, if you've downloaded this stuff from the web, you're going to be getting a warning that says that LAStools, not all of LAStools is free. And so it is important to realize that this really isn't exactly open source software, but Martin Eisenberg, the author of these tools, provides them all online. You can use them all. But what happens is certain tools are going to be limited in kind of what they can do a little bit. So that's really fine in this case. What I would want you to do now is browse to the merged file that you just created. So here's that file, and we'll bring it in. And we have a square that kind of corresponds to that. You can actually run the LAS viewer through this button here by hitting View, and it's going to tile that in. So this is kind of a handy way when you're using LAStools to just get a quick peek at the data sets that you're working with, just so you can kind of validate that this is what you want. So this is a quick view of the 3x3 9-tile data set. Now what I want to do is create a boundary. The output file here is set to shape. We can click on this box and specify, for instance, that we want to use our current directory, and that we want to write this out to merged.shape. We could probably, I think we probably won't need to put that appendix on here, but that's okay. We're going to just go ahead and hit run. So this is what the program is doing. Again, I usually use these tools from the command line, but this gives you a quick peek in terms of how this works. The README files for these are fantastic. They're all online, but they also accompany each file. So there's a README file for LAS boundary that you can open up that will describe in very good detail, including examples with a lot of different features that you can do, including filtering, transformations, classifications, lots of stuff that you can kind of do while you're doing another thing. So these README files come along with the tools that you're using, but they're also available online. So this is the tool as it wants to run. We're inputting our merged files, we're outputting this stuff, and we're going to output this shape file. So we hit start. This tool should run pretty quickly, so it's already done. Again, this is really one of the strengths of LAStools, is how quickly these tools run. If you're used to doing operations in ArcPro, I think you're going to find that this stuff goes much faster. Okay, so we're going to play around with a feature here in the next lab, but let's take a quick, or in the next section of the notebook, but let's take a quick look at what we've done so far. If we look at the directory that we've downloaded, that we've been working from, in my case this Blacksburg directory, we have all of our original files, and what I want to do is bring in this merged file that we had created. So here is our rendering of that. If we zoom in here, you'll get to see a little bit of the point cloud. So that's just a quick look. We can change how this looks, but I'm not going to worry about that at the moment. One of the things about ArcPro is that if you zoom out far enough, all you're going to see is just sort of this red box, and that's because it's trying to limit the number of points. Remember that Lidar point clouds are quite large, so we're probably looking at something close to 12 million points, and so Arc doesn't want to render all of those if it doesn't need to. What you can also do is bring in this merged shape file that you made, and it's going to look like this. So this is just a polygon that corresponds to the boundary of that Lidar data set, and we're going to use that in a second. Okay, that's it for this section. We will see you on the next section.